Hey everyone, how's it going? Just wanted to shoot a little video here to talk about how to use a microscope. So I want to demonstrate some of the techniques that we're going to use, and then we're going to practice these in lab. So let's get started. We're going to talk about the basics of scopes. We're going to be using both compound scopes and dissecting scopes, so we're going to practice with both. And I want to show you specific steps involved for using both of these, and then talk about capturing images. And like I said, we're going to practice this a lot in lab, and you're also going to be tested on it. So why do we mess with microscopes? Look, using a microscope is a skill for any biologist. I don't care what you study. If you are a biologist, you need to use a microscope at some point. I personally mostly use dissecting scopes. I very rarely use a compound scope, but other people will use exclusively compound scopes. And of course, there are electron microscopes, and there are even better microscopes. But what we're using in lab today, these are skills that you're going to use throughout the rest of your career. And it's really important that we teach you proper microscope skills. First off, it reduces the chance that you break one of ours, and obviously we don't want that, but also practice makes perfect. We need you to just get used to handling these things so that it becomes second nature, because like I said, if you're going to be a biologist, you're going to use these a lot. So you must take good care of my microscopes, okay? We don't have that many. We have to be very careful with them so that they'll last a long time. You will be tested on the proper handling and the proper use of these microscopes. And again, this is mostly, one, so that you learn how to use a scope without breaking them, and two, so that you learn good lab techniques. If I do see you using a scope improperly during any lab, I'll take points off, okay? So just please pay attention to this. But it's not too difficult. That's the good side. Okay, first thing we need to learn is just simply handling them. Anytime you carry a scope, you're using two hands, one on the arm and one under the base. I never want to see you carrying a scope with only one hand. One reason for this is that sometimes those things can become detached, and if you're only holding it with one hand, the bottom part can fall off and smash on the floor. Also, never touch the lenses with your disgusting fingers. You've got all kinds of oils and nasty stuff on your fingers. These lenses are the most expensive and the most delicate part of the microscope. And so when you need to clean them, not only do you not want to touch them with your fingers, but you need to use very special paper called lens paper. You don't want to use a Kim wipe. You don't want to use a Kleenex. You don't want to use your shirt sleeve. Because although these things feel soft to you, at a microscopic level, they're not soft. And they can scratch the lenses. But that lens paper is designed to clean the lens off without scratching it. Anytime you're using any of the knobs on there, don't force them. If you try to turn it and you feel resistance, something's wrong. And if you try to force it, you can strip the gears, and then you've broken the microscope. If there's something not working on a scope, just let me know. They do break down occasionally, and so we'll go ahead and get it fixed, but don't try to force it and break it worse. And also, we're going to say this again and again, don't smash the objectives. The objectives are the lenses that are part of the microscope. And on a compound microscope, if you're not paying attention and if you don't use proper technique, you can smash that lens into the thing that you're trying to look at. And since those lenses are very expensive, this is a bad thing. So a lot of our technique is designed to stop you from doing that. So you'll notice that Sophia is carrying the microscope using two hands, like she should. Now, whichever type of scope you're using, you're often going to need to calculate the magnification. Whenever you take an image or you use an image that you've captured from a scope, you need to tell people at what magnification you took that image. People need to know sort of what scale they're looking at. Most scopes, all scopes, have eyepieces, which are also called oculars, and those almost always magnify, and they almost always magnify 10 times, all right? So just the eyepieces themselves are going to add some magnification. Then usually there are other lenses in the body of the microscope which also add magnification, and those can vary from a little magnification to a lot of magnification. Sometimes if you're using a camera, the camera can add magnification, or sometimes the camera can subtract magnification because of the way the camera works. A lot of times they might subtract a little magnification to compensate for the camera. So you need to know all these things so that you can properly calculate the magnification that you're using. With just an eyepiece and an ocular, it's very simple. Just multiply them together, and that tells you the total magnification. And so, for example, if you're on a compound scope and you're looking at something with the 40x lens, then you know that the final image you're looking at is 400 times the actual size. You got a 40x lens, and the eyepiece is another 10x. You multiply them together, that's 400x, or it appears 400 times larger than it actually is. So that's pretty simple. Okay, as I mentioned, there's a couple kinds of scopes we're going to use here. The compound scope, this is also called a light microscope. That's for looking at small things, very small organisms all the way down to cells and cellular structure. Then we also are going to use the dissecting scope here in zoology, and that's for larger things. And so we're going to learn about each of those now. So starting with the compound scope, you see that there are several different parts, and you need to know all the names on this slide because it makes it easier to talk about it when you know all the names. Starting at the top, if you look at this ocular piece, these are adjustable, and so you can adjust the oculars for the width of your eyes, and we'll show how to do all these things later. You can also adjust the focus on one of these oculars, and so in this way each ocular can be at a slightly different focus, and that's because a lot of times your eyes are at a slightly different focus. And so if you have glasses or contacts, sometimes you don't have the same prescription in each eye. By having one of these oculars that's focusable or adjustable, that allows you to compensate for that so you can get a perfect image. This head down here that rotates contains the objectives, and the objectives are the lenses. And the larger and the longer the objective, the higher the power. But the trade-off is you see less of the slide. So when you zoom in on the slide, you're seeing less of the slide, but you're magnifying it more. The stage is where you set your slide with the object that you're trying to look at, and there's a little clip there that holds the slide in place. Then you can take this little knob underneath the stage and you can move the slide all around the stage. And so this is something that we'll practice. It'll become second nature to you pretty quickly, but in this way you can be looking through the objective, through the oculars, and you can move the specimen around without having to take your eyes away from the oculars. The more you practice this, the easier it gets. Underneath the stage, you have what's known as a condenser, and the condenser is raised up and down, is moved up and down using the condenser knob. And the condenser condenses the light, or it helps to kind of focus the light into a tighter beam, which goes through the object that you're trying to look at and makes it easier to see the object. So you don't waste as much light going around the objectives. The diaphragm also controls how much light makes it to the object. So the diaphragm is like an iris, like in a camera. And so as you slide that lever, the opening gets bigger and smaller. And so you can let in more light or less light based upon how much you open up that diaphragm. So the diaphragm and the condenser are both concerned with trying to control the light that gets to the object and then gets into the objective and then ultimately gets to your eye. The adjustment knobs are used to focus the image. And the way they focus the image is that they move this stage up and down. And so the larger knob that's closer to the body, that's the coarse adjustment. And so a small movement of that knob translates to a very large movement of the stage. whereas the smaller knob on the inside is the fine adjustment. And a small movement of that knob is a very small movement of the stage, all right? We only use the coarse adjustment knob with the lowest objective. And I'm going to hammer that into your brains. And that's because these knobs move the stage up and down. And so when you move that coarse adjustment knob, you're really moving that stage up and down a lot. And we're trying to not smash your slide into the objective. And so if you are looking at through one of the higher objectives, which are very long, and you move that coarse knob that moves the stage a bunch, it's very easy to smash that slide into that high power objective. But it's impossible to smash it into the low power objective. So you only use the coarse knob with the lowest power objective. I'm going to hammer that into your brains. On the higher objectives, the fine focus is all you need, and that's all you should be using. In the base, you have the light source. And the light source often also has a dimmer switch. And this also can be used to control how much light gets to the object that you're looking at on that slide. Okay, so let's talk about exactly how we're going to use this compound scope. Rule number one is to protect the objectives. Rule number one is that we do not want to smash the slide into that objective. And so everything we do is designed to prevent this from happening. Again, those objectives are very delicate and very expensive. Okay, so step one is we're going to crank the stage all the way down and load a slide onto the stage. We crank it all the way down so we give ourselves plenty of room to work. Step two is we rotate the head until we have the lowest power, rotate the head to the lowest power objective, right, which is the shortest one. And while we do this, we watch from the side. Anytime we change objectives on that microscope, we watch from the side. That way we can make sure that as we rotate that head, that objective doesn't hit anything. If we did this properly and we crank the stage all the way down, there really should be no chance that the objective should hit the stage, but we want to get into good habits. So Sophia has the stage cranked all the way down, and she watches from the side as she rotates to the lowest power objective, and then she inserts the slide onto the stage. Now that you've got the slide loaded up, you want to raise the stage all the way up, as far up as it'll go, and you'll use the coarse knob to do that. If you use the fine knob, it'll take forever. You'll spin it, spin it, spin it, because the fine knob doesn't move the stage very much. Use the coarse knob to raise that stage, and again, you're watching from the side. Although it should be impossible for the stage to hit that lowest objective, good habits are to always watch from the side to make sure that it doesn't happen. Now that you've got the stage all the way up, you can use the knob underneath the stage to move the slide around and try to center the object you want to look at over the hole in the bottom of the stage. So you want to get the object you want to look at, close to where it's going to be underneath the objective. And again, you're sort of watching from the side. These steps are all done so that we do not smash the slide into the objective. And again, a good habit, what I want you to always do, is to start with the stage as far up as it'll go. And then you focus by moving the stage down. In this way, it's almost impossible for you to smash that slide into the objective. Because if you start all the way up and it's not hitting the objective, then it can't hit the objective. And then you focus down. That's if you're on the lowest power objective, which is where you should always start, on the lowest power objective. Notice that Sophia is using the coarse knob to crank the stage all the way up, but she's watching from the side. Now that you've got the object ready to go, now you want to get the oculars adjusted for your eyes. And so the first step is to adjust them so that they're the proper width. And you want to adjust them until you can very easily see out of both eyes. If you're not sure if you're seeing out of both eyes, close one and then close the other. And you should be able to see in both of them. And if one of them is not in the right spot, then you'll be able to tell. This is something that, again, should become second nature to you the longer you do it. And I promise you, this will make using the microscope so much more comfortable. If you do not have those adjusted properly for the width of your eyes, you will constantly be fighting the scope and constantly be struggling to get a good image. But you just want to get your eyes a comfortable distance from the oculars, and you want to adjust them until you can sit there comfortably and see with both eyes. That's how you get the best image. So once you get them adjusted for the width of your eyes, use the coarse knob and focus down until the image is more or less focused, until the image looks good. And since you've cranked the stage all the way up, the only way you can move it is down. And so now you can move the stage while you're looking through the oculars because you've ensured that it's not going to hit anything. If you have to stop and move the stage back up, that's when you want to come off the oculars and look from the side. But if you know the stage is all the way up and you're only able to focus down, then you can look through the oculars while you're focusing down. Here you can see how the oculars move in and out. And now Sophie is adjusting them to the width of her eyes. And now she's using the coarse knob to adjust down until the image is focused. Now that the image is pretty well focused, we're going to fine-tune the focus. And so the first thing we're going to do is figure out which ocular is the adjustable ocular and close that eye. Then you're going to use the fine adjust, the fine focus on your microscope and adjust until the image looks perfect out of the other eye, right? And so what you're doing is you're closing the eye for the ocular that is adjustable, so the eye that's open, you can still adjust it, but you have to adjust it using the fine focus. When the image looks good, now you know that one ocular is in focus on this image. Then you close that eye and you focus the other ocular, but this time you don't use the knob on the microscope, you adjust the ocular itself. And in this way, when the image looks good, now it's focused for both of your eyes. Now, you should only have to do that once, right? Once you get that adjustable ocular focused, then it should be fine no matter what. You can just use the fine focus, with both eyes in the future. But this is the first time. But this is how you compensate if your eyes do not have exactly the same prescription. And so we get a perfect focus even if your eyes don't focus the same. So Sophie has already closed her left eye and used the fine knob to focus on her right. Now she closes her right eye and adjusts the ocular to focus on her left. So now, once we have the object focused on low power, we often want to go to a higher power so we can get better magnification. And so we're going to need to switch to a higher powered objective. This is where you need to be most careful, because this is when you're most likely to smash that objective into the slide. So what you got to do is you got to come off the oculars, move to the side, rotate that to the next highest ocular while watching from the side. You watch from the side because then you'll be able to tell if that objective is going to hit the slide. Do not rotate the objective while you're looking through the oculars, because you might smash that objective into your slide because you're not watching, and that's what we're trying to avoid. So anytime you're changing objectives, you always look from the side to make sure you're not going to hit anything. Also, Don't skip objectives. Don't go from the lowest power objective all the way to the highest. That'll never work. You want to go to the next highest, get a good focus, then go to the next highest. And again, if you skip objectives, if you go from the lowest all the way to the highest, you're very likely to smash that objective into the slide. If it's going to hit, there's nothing you can do about it. You can try and make a thinner slide, or you just have to say, look, I can't look at this object under any higher magnification. That's just how it is. Once you get the objective moved, then you can come back onto the oculars and focus, but you only use the fine adjustment knob. You never, 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 never use the coarse adjustment when you're on those higher objectives. You only use that for the lowest objective, and that's it. Again, if you're going to smash the slide if you use that higher that coarse focus on those higher objectives. So don't do it. If you can't get a good focus on that higher objective, you need to back off to a lower objective, get a good focus, then turn it back in, and then try again. Also, remember, the higher the magnification, the smaller the aperture, so the less light that makes it through to your eye. So you might need to compensate by adjusting the diaphragm, adjusting the condenser, and or adjusting the dimmer to increase the amount of light that actually makes it to your eye. So you see that Sophie is rotating to a higher powered objective, but she watches from the side. And now that she's on a higher powered objective, she only uses the fine control knob to focus. And so this is what I just said a second ago. As the magnification goes up, the aperture gets smaller, and so you need to increase the light. Light control is often key to a good image. And so the difference between a good image and a great image is often how well you can control the light. This also controls the contrast, which again is very important to making a good image. So when you're done, you need to reverse all these steps to unload the microscope. And so the first thing you do is you need to turn the objectives all the way back to the lowest objective. But again, anytime you do this, you're watching from the side to make sure you don't hit anything with those objectives. Then crank the stage all the way down to give yourself plenty of room to work, and then you can remove the slide. Once you're completely done with the microscope, you want to wrap the cord around it, make sure that you cover it. We always want to cover these things. These are precision instruments, and little specks of dust that get into the gears and get into the objectives make a big difference. So here you can see Sophia's watching from the side as she rotates to the lowest objective. Then she uses the coarse knob to lower the stage all the way while watching from the side. This gives her room to reach in and pull out the slide. And then she can shut off the light and we're done. Okay, just some final thoughts here, talking about the compound scope. If you have glasses, it's sometimes a little bit more difficult. When I wear my glasses, it's difficult because you can't get your eyes as close to the objectives, and now you've got an extra set of lenses, but it can be done. So you might want to try and, use the scope without your glasses. The problem there is that when you come off the oculars, if you're like me, you're blind as a bat. So it can be done with glasses. Again, this is why we practice. When you're using the compound scope, everything in the image is backwards. And so it's upside down relative to the slide. And so when you move the slide, up is down and left is right. And so that's another reason why you want to practice using that knob underneath the stage. If you have to think about it, I need to look to the left of the slide, so I need to move the slide right. You'll get confused. You just want to practice so that as you move that slide around using that knob, that control knob, you'll get really good at moving the slide to where you want it to go, but it's always going to be backwards to the real world. Some pro tips: the higher the objective, the finer the focus. That is, the less you want to move the slide. It's very easy to get off focus and never get it back on those high objectives. So if you switch to a high objective and you're trying to focus and you just can't focus, that happens all the time. The best thing to do is to just back off, go back to the lower objective, refocus, and try it again. And then you only need very small adjustments to get the difference between bad focus and good focus. If you're looking through the objectives and you're moving the slide, but nothing in your field of view moves, you're not looking at the slide. You're looking at the bottom of the lens or something else. You need to refocus and make sure you're focused on the slide. So that's one way to tell if you're actually looking at the slide. Move it around. If the stuff in your field of view doesn't move, you're not looking at the slide. If you're looking at something on the slide, but you can't find what you're looking for, you might be focused too low or too high. You know, that seems crazy that on a little slide that's very thin, you could be too high or too low. But remember, this is a microscope. And so you're working at a very different scale here. So just try to adjust, focus a little bit lower or a little bit higher, and often you'll find what you're looking for. Okay, let's go ahead and take a look at some common mistakes and make sure that we don't make these mistakes. So let's demonstrate some common mistakes that I often see students make while they're using the microscopes. For example, here Sophia is on the lowest power objective, but she's focusing up with the coarse knob. You should always focus down. Here is another very common mistake. You will notice that Sophie changes to a higher power objective, but she does not look from the side. This is a very big no-no. So here's another very common mistake. Sophia will switch to the higher objective, and she will look from the side like she's supposed to, but while she is switching the objective, she moves the stage out of the way and then moves the stage back. This will never work because she will probably hit the objective and she definitely will not be able to get it focused properly. This is a more minor mistake, but you will notice that Sophie unloads the slide, but she does not rotate to the lowest power objective and she does not lower the stage. So I saved one of the biggest mistakes for last. Here you will see that Sophie is trying to focus on one of the higher objectives, but she is using the coarse focus knob, not the fine focus knob. And this is a huge mistake. Okay, last thing about the compound scope, whenever you're looking at things with the compound scope, you often need to mount them. You need to put them on a slide. You can't just stick something under the microscope. Most commonly, we do what's known as a wet mount. And so we put the thing we want to look at on a slide, we add a drop of water, then we drop a cover slip over the object. And so this protects the objectives from, they don't get wet, they don't get stuff on them. It helps to hold the item in place. It helps to keep everything at the same thickness. Sometimes we'll add a stain to that to help things show up a little bit better. So we're going to practice this in lab too. If you have really high objectives, really high magnification, water is not good enough. Water does not bend the light properly, so you need something called immersion oil. In zoology, we're not going to be looking at anything that small, but in other classes you might. When you're using these cover slips, be careful. If they're glass, they're very thin, they're very fragile and easy to break, and it's easy to cut yourself. Most of our cover slips are plastic, so it's not a big deal. If you do have glass cover slips, when you're done, just throw them in the broken glass. Don't try to reuse them, because if you try to clean them, you're just going to snap them and then cut yourself. The slides, however, the slides can be rinsed off, dried off, and reused. So don't throw away the slides. Okay, now let's talk about the dissecting scope. And the dissecting scope is often a lot easier for people to use. Here's all the parts to the dissecting scope, and you need to know these. The trinocular port, A compound scope can also have this. This is where you can attach a camera. And so this is a way you can attach a camera and still use the oculars. And sometimes the trinocular port adds, and sometimes it subtracts magnification, and sometimes it doesn't do anything to the magnification. The oculars are adjusted the same way as on the compound scope, and so you want to adjust them the same. Dissecting scopes don't have a series of objectives like the compound scope. They just have like a zoom lens. And you've got this zoom knob over here. And so you just have a continuous zoom. So as you're looking at the object, you could just zoom in and out. So you sort of have an infinite number of magnifications on here. The zoom control does have numbers on it. And so once you have an image, you can look at that number, and that number tells you how much your objective is magnifying it, and then again you multiply that by the magnification in the eyepiece to get the total magnification. You only have one focus knob on the dissecting scope, and no matter what the magnification, you can use this focus control. And since we don't have these objectives, we don't have to worry so much about smashing into things. The dissecting scope is designed for you to be able to work underneath it. You got plenty of room under there to do your work. Dissecting scopes will either light from above, which is called reflected light, or they can light from below, which is called transmitted light. And you have a control for each of those lights, and you can adjust the position of that light from above. And sometimes you use both, but rarely. Usually you use one or the other. Rule number one of the dissecting scope is keep it clean. If you're dissecting things, you got blood and guts and fluids everywhere, so we always want to make sure we clean these up. To use a dissecting scope, it's pretty straightforward. You place the item under the scope. If you're using light from below, you need a clear container, right? You need something that allows the light to come through. If you're lighting from above, you can either use a clear container or an opaque container often works better. Again, you want to start with the magnification adjusted to its lowest setting. You want to focus and adjust the oculars in the same way that you did with the compound scope. Then you want to adjust the magnification and light as necessary. So you want to zoom in, zoom out, adjust the light, whatever you got to do to get a good image. And then when you're done, again, clean it up, turn off all the lights, wrap the cord around it, and cover it up. So it's not as complicated as the compound scope. The only final thought here is everything is right side up. So whereas in the compound scope, everything is reversed, in the dissecting scope, it's designed so that you can work under there. So left is left and up is up. So as you're holding something under the dissecting scope, as you move it around, the image you're looking at moves in the way that you would expect. Finally, we want to talk about capturing images from either scope. Often scopes have that trinocular port or they have a built-in camera. These are the best. That's because you can look through both oculars and still be able to take a picture. We have some cameras that mount on one of the oculars. Those work very well, but obviously they block one of the oculars, so they're kind of a pain, but they take pretty good pictures. Holding your phone up to the ocular is okay. It's difficult to get it exactly the right distance from the ocular. And so it's difficult to hold your hand steady sometimes. We have some camera mounts that you can put your phone in that will help with this. The upside is with your phone, you can just keep taking pictures and eventually you're going to get a good picture. Now, if you take a picture with your phone, you often get something called vignetting. And you can see this here, maybe you've seen this before. It's when you get these dark spots around the outer edge of the image. This is unprofessional. This does not look good. I don't want you to turn in any images that look like this, all right? The upside, again, of your phone is that it takes very high resolution images. So you can crop all this stuff from the outside and then enlarge the image and it still looks good. And so don't turn in a picture like this on your homework. What you need to do is crop those bad parts, stretch out and zoom on the remaining things, and this is the same image. This is what you should end up with, okay? And so that really only tends to happen when you use your phone. So that's just a tip. Okay, so that's our introduction to microscopes. We're going to practice this quite a bit in lab. We're going to be using these all semester. So let me know if you got any questions, and I'll see you in lab.